Okay, so what we're going to be looking at today is how to actually make solutions. So what you guys looked at earlier this week is you guys looked at this idea of solutions and being able to identify the concentration of a solution. And you learned about this idea of molarity, which is a way that we can identify how concentrated a solution is. So now what we're going to do is say, okay, so we know what molarity is. Now let's talk a little bit about how do we actually make these solutions in a lab. And so I'm going to introduce a couple new ideas and solve a problem. So here's our question that we're going to be working on. How do you make a 0.25 molar solution of copper chloride if you need to make 500 mils? So we need to make 500 milliliters of a 0.25 molar solution of copper chloride. Now, a couple different things. Copper chloride is right here. Copper chloride is a solid, so we're going to need to dissolve it. And the other thing that I want to note is that when we are talking about making a solution, unless it specifies, we will always be making a solution in water. So water will always be what dissolves unless it specifies that we're going to be making it in something maybe hexane. So assume that we always do it in water. So really what we need to know is we need to know that we're going to make 500 milliliters total. And the next thing we need to know is how much copper 2 chloride are we actually going to be putting in the solution? So we need to know the mass, and we can actually get the mass from this information. So a couple things that we're going to need to do. So we have our copper chloride right here. We have a water bottle with some water. We have something called a volumetric flask. So this is what a volumetric flask looks like. This is a 500, you see right here, 500 milliliter volumetric flask. And right here at the mouth, I don't know if you guys can see it that well, but right here at the mouth, there's a little line. And this line reads exactly 500 milliliters. So when we are done, we want our solution to be exactly at that line. So volumetric flasks are specifically created so that we can make very exact measurements for solutions. So a volumetric flask is a very common tool. So it kind of has this mouth, and I'll show you guys how to use it. And then of course we're going to be using an electronic balance. So I have my electronic balance right here. And we're also going to be using some weigh boats. So some plastic little weigh boats. We're going to be using these to measure our copper 2 chloride in. What's really nice about these is because, as you guys can see, the mouth of the volumetric flask is pretty small. What's nice about these is that you can kind of just create like a little funnel out of it and funnel it straight into our volumetric flask. Okay, so the first thing we need to do, I'm going to go ahead and write down some steps and start solving. So the first thing we need to do is we need to know how much copper 2 chloride goes into the volumetric flask. Okay, so let's talk a little bit about solving for this part. Now, we know that we have 0.250 molar solution. Remember that molarity has a unit of moles over liters, so we could really say it's 0.250 moles of copper 2 chloride over 1 liter of solution. So notice that I'm able to create kind of like a conversion factor, breaking apart this. And again, molarity has units of moles of your substance over a liter. Now we have 500 milliliters, and 500 milliliters equals 0.5 liters. So that's just quickly converting milliliters into liters. And so now what I'm going to do is I am going to set up a problem to figure out the number of moles I need for my 0.5 liter solution. So I'm going to go 0.5 liters times 0.250 moles over 1 liter solution. Notice that I set this up and now my units cancel out and I'll get moles. So what this tells me is I need 0.125 moles of copper chloride. copper 2 chloride. Now, we're not quite there yet. We're very close. What you want to remember is that we cannot weigh out moles. So we need to convert moles to grams. And we know how to do that. We're going to use our molar mass. So using our periodic table, we're going to calculate our molar mass of copper 2 chloride. So this is a periodic table that you guys have access to. This is the one from ptable.com. So we want to figure out the mass of copper 2 chloride. So copper has a molar mass of 63.456. And we have 2 chlorine, so I'm going to multiply that by 2. So 2 times chlorine, which is 35.45. So that gives me a molar mass of 134.446 grams per mole. So now what I'm going to do is I'm going to convert my moles into grams using the molar mass. So 0.125 moles of CuCl2 times, now I want moles on the bottom, so it's 1 mole. It's going to be 134.446 grams. Now I'm going to multiply that by 0.125. And so what this tells me is I need to weigh out 16.8, we'll say 1 grams of copper chloride. So now I know how much I need to weigh out. And that's really the only math I need to do is just that one conversion, because I need to figure out how much of my copper chloride do I need to weigh out to put in my flask. So now let's talk about making the solution. So the first thing I'm going to weigh out is I'm going to weigh out my copper chloride. And when you weigh out your copper chloride, you need to make sure that you are exact. You don't want 16.82, you don't want 16.8, you really want to try to get 16.81. So we're going to go ahead and use a balance. I'm going to put my balance right here off to the side. I'm going to be using my weigh boat. Put that on, turn this on, and I'm going to weigh out exactly 16.81 grams of copper chloride. Okay, so let's go ahead and start weighing this out. So here is that. I'm going to start weighing this out. Just start piling it in there. Looks like I'm going to need a lot. I'm at 6.91. I'm using my scoopula. As I get closer, I'm going to try to get smaller and smaller amounts. So I'm at 16.14 and I want 16.81. So I'm going to just kind of tap it in. 7.2. Tap a little bit. Okay, I went over, so let's go ahead and take a little bit out. 9.2. Okay, just a little bit. Almost. There you go. Okay, so I got 16.81 exactly. So once you have that weighed out, what you want to do is you want to grab your graduated, excuse me, your volumetric flask. And you are going to quantitatively add it to your volumetric flask. And what that means is that I want to make sure that every bit of what I weighed out gets in there. So the first thing I'm going to do is kind of create a funnel and slowly put it in. So I'm kind of just shaking and adding it, making sure that I don't let any fall out of the sides as I add it in. This might take a minute. As I'm getting it all in there, still have a little bit more. All right, and once I have pretty much emptied this, I want to make sure that any last bits aren't left in there. So here's my volumetric flask. You can see that there's a little bit of blue. So what I'm going to do is I'm going to take my water bottle and I'm going to spray down this into the volumetric flask. So I'm going to spray it in there because I want, again, every single bit of that copper 2 chloride in there. All right. So I have it down. The next thing I'm going to do is notice that there's a little bit in the mouth. I'm also going to wash down the mouth. I want to make sure, again, that all of that's down in the solution. Okay. So now what you want to do is I'm going to add about maybe 4. So this is 500 mils up to the line. I'm going to add some water. I'm going to add enough just so I can dissolve this. I don't want to add too much. I don't want to add it up to the neck, but I'm going to add water to start dissolving this. So here I'm going to add just some clean water. I'm adding it to here. And again, you don't want to fill it up too much because what you want to be able to do is you want to be able to shake it around enough that you actually dissolve everything that was solid that you put in there. So I'm going to stop just for a minute. So here it is. You can see that it's definitely not full, but I'm going to shake. I'm going to move around. I'm going to swirl it and shake it up. And I want to try to get it all dissolved. I want no more little floating solids. And actually, that looks like that might have done it. So now what I could do is I'm going to use my beaker and I'm going to continue filling up with water. But once I get close to the neck and close to the line, I'm going to start doing drop by drop with my water bottle. Because if you go past this line, you can't take water back out. So once you go past that line, you need to remake your solution. So it's always really careful to make sure that you don't add too much water. It is not a fun thing to remake your solutions. I have definitely done that way too many times. So I'm going to add my water, filling it up. I might need to grab a little bit more water in my beaker. Yeah, so I'm going to go grab a little bit more water so you guys can see I'm not quite filled yet. Let me grab a little bit more water. Okay, so let's go ahead and fill it up to the line. Or not to the line, we're going to fill it up just below the line. And then once we get to the line, we fill it up with the water bottle so we could add it drop by drop. Okay, so I filled it up. You can see that the water's starting to come up to the neck. Now I'm going to drop by drop fill it up. Now when I fill it up, you guys can't see me, but I am kind of bending down so that my eyes are in level with the line. So I'm going to go ahead and I'm going to start adding water in here and making sure that I don't get above that line. Again, you would have to remake your entire solution. So I'm getting really close and there. Okay, so I am now at my line. If I turn it, it's going to go below the line, but I'm now at the line. Now, the last thing I'm going to do is I'm going to cap this, and I'm going to just invert it a couple times to make sure that the water gets fully mixed in. Okay. And so that is how you make your solution. So now what I have right here in this beaker is I have my 0.25 molar solution of my copper 2 chloride. So my 0.25 molar solution of copper 2 chloride. So let's go ahead and finish writing down our steps since I kind of stopped right after we did the math. And let's write down our steps for doing this problem. So my step number 2 is weigh out exact amount of solute. So this is, again, is what we dissolved in the solution. Then we're going to add all solute to volumetric flask. The next step that I did is I added approximately half the volume of water and swirled, let me move this up, till solute dissolved. Then the last step that you do is that you fill volumetric flask to, flask to line and invert several times. Invert just meaning to turn it upside down so that we mix all of the water. So that is how you make your solutions. So next, what I'm going to do is I'm going to go ahead and walk you through just another problem doing some of the math involved in making solutions. So once you have these notes down, go ahead and watch the next video. And then after that video, you will have the opportunity to start working on some of these problems on your own to see that you can solve these molarity type problems.